do this. Okay, camera's on. Okay, so yeah, let's get this afternoon going here. I'm taking full advantage of ChatGPT. Hello, I'm Mike Pavlin. I'm a faculty member at Laurier University and co-chair of Laurier Heterodox Campus Community, along with Will McNally and Jeff Horseman. Heterodox Academy is, speaking here to the people out there in the future here, is an international organization of thousands of academics which advocates for policy and culture change that ensures our universities are truth-seeking, knowledge-generating institutions grounded in open inquiry, viewpoint diversity, and constructive disagreement. In this spirit, Laurier HxA seeks to bring diverse viewpoints to campus and facilitate conversations on some difficult topics. Before I introduce our speaker, I'd like to say just a couple words about how this event came about. So this event was initially conceived as a conversation. Two parties expressing divergent views on a topic and discussing their differences with collegiality and in good faith. That was the goal. But we failed to find a partner for Ross, for our speaker, not as a result of a lack of effort. We emailed many climate scientists and activists, individuals receptive and helpful for a workshop I recently hosted on sustainable enterprises, answered curtly or not at all. We had a long exchange with our faculty association, Climate Action Committee, offering various ways to participate. Despite a rationale that cites that a global climate crisis is profoundly reshaping our world, and a mandate for connecting, convening faculty across the university to share ideas, debate issues, and educate and mobilize one another, they opted not to participate in any way, citing a lack of scientific expertise. And they also opted not to attend. So we think this is a mistake. There are a host of reasons that this conversation needs to happen, not least of which is the chasm between the academic consensus and public opinion on this topic. So while the climate emergency has become the orthodox view across academia and a large portion of the media, if you just look at that, you might believe that the science and policy is settled. But a late 2024 Abacus survey found 37% of the population not even moderately concerned about climate change. That was up 14% from the previous year. And observing consumer actions, what an economist might call revealed preferences, doesn't show anywhere near that level. One of the most obvious, and here we go, one more check, and economical choices that can be made to reduce one's greenhouse gas footprint is to purchase an electric car. In Ontario in 2024, out of 13 people that had that decision to make and faced that decision, 1 out of 13 selected the green option. Yeah, and should you think this doesn't represent your social circle, here's a picture of our electric vehicle parking at the Lazaridis School. And you'll note that that is not was it the Lightning, or nor is it a Cybertruck. That is a good old-fashioned gas-powered pickup truck. Yeah, and I have a beautiful view of this parking lot from my office, and I can say for certain that this has not been cherry-picked. So, regardless of where you stand, I hope that we can all see the value of a rigorous public debate on the risks and policy and the appropriate policy response with respect to climate change. And I couldn't be happier than to welcome Ross McKitrick here to get Laurier moving along that path. Ross McKitrick is a professor of economics at the University of Guelph, where he specializes in environment, energy, and climate policy, on which he has published very widely. His book, Economic Analysis of Environmental Policy, was published by the University of Toronto Press in 2010. He has a background in applied statistics, which he has applied in many ways, including collaborations across a wide range of topics in the physical sciences, including paleoclimate reconstruction, malaria transmission, surface temperature measurement, and climate model evaluation. Professor McKitrick has made invited academic presentations around the world and testified before the US Congress and committees of the Canadian House of Commons and Senate. And this short biography there doesn't leaves out much of the scope and impact of his academic contributions, which are with over 3,600 citations, as well as the importance of his contributions to public discourse, which includes, but is far from limited to, interviews with the New York Times, op-eds with the Financial Post, and discussions of his work in The Economist and Globe and Mail. So Ross will speak for about 40 minutes, and in the remaining time, I hope we can have a robust discussion and Q&A. During the seminar and discussion, let's stick to what we call the HxA way. Make your case with evidence, be intellectually charitable, be intellectually humble, be constructive, and be yourself. Please, Ross, thanks so much for coming, and the floor is yours. So swap those slides.
Great, thanks very much. Well, I want to say it's a real pleasure to speak at a Heterodox Academy event. This is the first time I've done so, and every so often I'll be reading a really interesting essay by someone, and then I'll learn a bit about them, and inevitably it turns out they're connected with the Heterodox Academy somewhere. So this is a really valuable community in the academic world, and I'm going to be a bit of a letdown because actually my talk today will be pretty boring. I'm just going to read a lot of stuff from the Intergovernmental Panel on Climate Change, and so I don't mind if it gets really tedious and you have to get out your phone and look at what's going on in the world. That's fine. But the question is, does the IPCC say it's an emergency? Actually, the simplest way to answer that is I could put up the Sixth Assessment Report and do a word search on it for catastrophe, no hits, emergency, no hits. I think existential crisis, no, it's not in there. So I'll show you what is in there though. It is commonly claimed that climate change is an emergency, and various synonyms of that, like existential crisis and so forth. Now, what climate change really refers to is a slow warming trend. All the variability of weather is wrapped around a slow warming trend happening over time. And that doesn't seem too scary. And I can tell you in the economic models it's not scary. 2018 was the same year that the whole climate emergency declaration got launched, and in that year, economists saw fit to give a Nobel Prize in economics to William Nordhaus, who did his work on integrated assessment modeling of climate policy. And no matter how many times he ran his model and did all the tweaks and everything, it kept coming back to, this is a small issue that we should do modest things for the next few decades and maybe more aggressive policies later in the century, but we just can't justify any kind of radical restructuring of the economy. And there the problem is that as much as we can add up the estimates of the costs, they're still small compared to the massive costs of trying to stop it from happening. And so Nordhaus's model keeps coming to the conclusion that for the most part we'll just live with it. And so he's not a popular guy outside of economics, but his work was really solid. And so he was awarded by the profession for that. So given the fact that a little bit of warming isn't a very frightening concept, a lot of the discussion goes to extreme weather. And here the assumption will be that extreme weather in all forms is not only bad, but it's getting worse. And it's getting worse due to greenhouse gases. And every instance of an extreme weather event can be attributed now to climate change, and we can just say they're all getting worse. So we're going to ask, is this what the IPCC and similar expert groups say? Now, the IPCC, if you don't know, the Intergovernmental Panel on Climate Change, it's been around for a long time. The membership constantly changes, but it is the official panel, you might say. Working Group 1 is the group that puts out every 6 years or so an assessment of the current state of climate science. And because it's so authoritative, there is this sense out there that, well, we will go with what the IPCC says. They will have the last word on the subject. And now I've published things that disagree with what the IPCC says, so I'm not going to just say, believe everything they say. But it's still the starting point. We're talking about extreme weather. The IPCC regularly surveys extreme weather. We should find out what they have to say about it. And the answer is no, they do not say that extreme weather in all forms is bad and getting worse due to greenhouse gases. Now, I want to give you some examples of how this discussion plays out in public. So this fellow, David Malpass, he was the president of the World Bank, and he made an offhand comment, this would have been in 2022, that he didn't see climate change issue as a crisis. And when someone in a public setting or position of any authority makes something that's a little skeptical sounding, there are armies of people that will jump all over. And so in this case, he was assailed by journalists demanding to know, does he accept that climate change is a crisis and already leading to more extreme weather? And so he just kind of ducked it by saying, I'm not a scientist, and he washed his hands of it. But he nearly lost his job over that. And by the end of my talk, I hope you'll realize that all he had to do was say, well, I just go with what the IPCC tells me, and confident that none of the journalists who were haranguing him had even looked at it. So, but then he hadn't looked at it either, so he wasn't in a position to say. Lisa Raitt, a former federal MP in Canada, cabinet minister, I published an op-ed, when was that? 2019, about a paper published by Roger Pielke Jr., then a meteorologist at Colorado State, going through a lot of what I'm going to tell you today. Just basically a review of the extreme weather issue and pointing out that we don't have evidence that it's getting worse. And he was attacked by politicians in the US for it, ran into a lot of trouble for saying this, even though, again, he was just quoting the official data and the official reports. And it's quite a story. So I put that op-ed out. Lisa Raitt retweeted it. And then she got so harangued and harassed, it was worse than anything she'd had, and she was bullied into deleting the tweet and issuing an apology for it. Now the irony is the story was about a scientist who did a summary on the issue that said it's not happening, and so politicians attacked him, and then a politician retweeted it, and then she got attacked by activists and forced to retract her comment. Now, there was a debate in the House of Commons in October 2018 on, I think it was the declaration of the climate emergency in the House of Commons. And so there are lots of examples I can give you like this, where MPs stood up in the House of Commons and just started offering anecdotes about extreme weather with the assumption that they're all getting worse, whatever's happening. Now, some of them are, admittedly, they're up here for comic relief, but so this young NDP member said not even 6 months ago, 6 tornadoes hit the National Capital Region in Hull and Ottawa. This was unprecedented, and these kinds of events are increasingly common. Earthquakes, we're talking about climate change, but tsunamis, okay, that's not really connected. Flooding, forest fires, and I could go on. All right, so again, no data. There's an anecdote about one bad cluster of storms, and then just the assumption, flooding, forest fires, they're all bad, they're all getting worse. Catherine McKenna, the environment minister at the time, we have seen forest fires that are burning longer and brighter than ever. We have seen floods, we have seen droughts. Now that's true, we have seen floods and droughts and forest fires, but her point was we have to act because these are getting worse and worse. Now this one, I shouldn't really include her, but I can't resist this one. Today in question period, I was shocked to hear an opposition member complain about the early snowfall in Alberta and Saskatchewan that is jeopardizing cereal crops, and then turn around and call for the elimination of the carbon tax. How is it that the opposition does not understand that the early snowfall in Alberta and Saskatchewan is caused by uncontrollable global warming? So in this case, the extreme event is an early snowfall. Now, of course, if there was no snow, she would have said that was global warming too. But everything is connected to climate change, and it's all getting worse. This one I just noticed yesterday in a Bloomberg News article, the comment here, renewable energy keeps getting cheaper to install and use. As my Bloomberg opinion colleague Liam Denning has pointed out, the trillions of dollars needed to achieve net zero must be weighed against the trillions in damages threatened by climate change. Now I snipped this out because I will use that in my class to ask the economics students, can you please tell me what's wrong with that sentence? The answer being, we don't compare total to total, you compare the margin. So what you need to balance is the cost of the policy versus the change in the outcome that you think the policy will achieve. But the final sentence here, the US is already experiencing an insurance crisis because of the rising costs of climate-fueled natural disasters such as wildfires and floods. Okay, so there it is again. Wildfires and floods getting worse. All right. So we could take it that everybody knows climate change is causing more flooding, more extreme rainfall, droughts, tropical cyclones and hurricanes, tornadoes, wildfires, etc. The problem is the IPCC has never said this, and they do not currently claim it. So as I go through this, I'm going to use some short forms. The first is SREX. That's the IPCC special report on managing the risks of extreme events and disasters to advance climate change adaptation. The special report on extreme weather is called the SREX. That was 2012. And in 2013 was the fifth assessment report, and I'm going to be referring to the Working Group 1 contribution. And then the AR6 is the IPCC sixth assessment report, so that's the most recent one. That was 2021. Again, I'm referring to Working Group 1, which is the scientific panel. Now the IPCC has a bunch of other panels, and they're always putting working groups or special groups together. And this is where they've let in all kinds of people, like Working Group 3 is on mitigation, so that's where there's a lot of really low quality work that gets done. But Working Group 1 is where the scientific panel works. Then also we have Canada's Changing Climate Report from the Government of Canada in 2019, the CCCR, which, okay, that's getting a little dated, but it's important to bear in mind that that would have been the report that came out around the same time as all the climate emergency declarations. So all of these reports are especially pertinent because they're the ones that, if at the time you've heard these claims, these would be the reports that people could look at. Okay, so let's start with Chapter 12, Table 12.12 in the IPCC Sixth Assessment Report. Now this table is a summary of questions about all these categories of extreme weather. So I know you can't read it, but I'll put up a more readable summary. But each of those rows refers to a category of extreme weather. And then the color coding is in the columns. And in the first column, the question is already emerged in the historical period. And what they mean specifically is a climate-driven change in whatever event they're referring to. A dark blue square means, yes, an increase that they're prepared to attribute to greenhouse gases. Dark orange would be a decrease that they're prepared to attribute to greenhouse gases. Light blue and light orange means, yes, they've noticed a change, but they can't attribute it specifically to greenhouse gases. And white means there's no indication even of a change. So right away, you'll notice that most of those squares are white. Most of those rectangles are white. So, the IPCC has concluded that a signal of climate change has not yet emerged beyond natural variability for the following phenomena: river floods, heavy precipitation and pluvial floods, landslides, droughts of all types, severe windstorms, tropical cyclones, sand and dust storms, heavy snowfall and ice storms, hail, snow avalanche, coastal flooding, and marine heat waves. All right, so that's a quick summary to sort of prime you for what's to follow, which is, as we go into detail, the story is going to be over and over. Yes, lots of river floods happen. We don't really see a specific pattern to them globally as far as a trend up or down, and we can't attribute changes to climate change. So let's start with floods. So this is a 2012 report. In the United States and Canada during the 20th century and early 21st century, there is no compelling evidence for climate-driven changes in the magnitude or frequency of floods. Research subsequent to the AR4, that's the fourth assessment report, which was the previous assessment report to this one, still does not show clear and widespread evidence of climate-driven observed changes in the magnitude or frequency of floods at the global level based on instrumental records, and there is thus low confidence regarding the magnitude and frequency and even the sign of these changes. And then we get to the fifth assessment report. The AR4 did not assess changes in floods, but AR4 Working Group 2 concluded that there was not a general global trend in the incidence of floods. SREX went further to suggest that there was low agreement and thus low confidence at the global scale regarding changes in the magnitude or frequency of floods or even the sign of changes. AR5 Working Group 2 assesses floods in regional detail, accounting for the fact that trends in floods are strongly influenced by changes in river management. There is currently no clear and widespread evidence for observed changes in flooding except for the earlier spring flow in snow-dominated regions. In summary, there continues to be a lack of evidence and thus low confidence regarding the sign of trend in the magnitude and or frequency of floods on a global scale. And then the most recent AR6, this comes at the end of the section of the chapter. In summary, the seasonality of floods has changed in cold regions where snowmelt dominates the flow regime in response to warming. Confidence about peak flow trends over past decades on the global scale is low, but there are regions experiencing increases, including parts of Asia, Southern South America, Northeast USA, Northwestern Europe, the Amazon, and regions experiencing decreases, including parts of the Mediterranean, Australia, Africa, and the Southwestern USA. So, that's floods. Now that would be the kind of text that the IPCC puts out there, and that's all they're going to say on the subject. So if you want to summarize it by saying, yeah, there are more floods, and these floods that happen, it's climate change, you're on your own. That's not what you get from the IPCC. Now, related to floods is rainfall. So the AR5, in summary, confidence in precipitation change averaged over global land areas is low for the years prior to 1950 and medium afterwards because of insufficient data, particularly in the earlier part of the record. Available globally incomplete records show mixed and non-significant long-term trends in reported global mean changes. Extreme rainfall, SREX. More locations and studies show an increase than a decrease in extreme precipitation, but that there are also wide regional and seasonal variations, and trends in many regions are not statistically significant. AR5. In summary, further analyses continue to support the AR4 and SREX conclusions that it is likely that since 1951, there have been statistically significant increases in the number of heavy precipitation events in more regions than there have been statistically significant decreases, but there are strong regional and sub-regional variations in the trends. In particular, many regions present statistically non-significant or negative trends, and where seasonal changes have been assessed, there are also variations between seasons. And for Canada, that climate change report that I mentioned, this one, you have to search for this. You have to know what you're looking for because they don't highlight this kind of information. But the observational record for Canada has not yet shown evidence of consistent changes in short duration precipitation extremes across the country. And then the sixth assessment report, in Canada, there is a lack of detectable trends in observed annual maximum daily or shorter duration precipitation. So, extreme rainfall, another bust. How about droughts? All right, SREX. Recent droughts are not unprecedented. Much more severe and longer droughts occurred in the past centuries with widespread ecological, political, and socioeconomic consequences. In North America, there is medium confidence that there has been an overall slight tendency towards less dryness, although analyses for some subregions also indicate tendencies toward increasing dryness. The most severe droughts in the 20th century have occurred in the 1930s and 1950s, where the 1930s Dust Bowl was most intense and the 1950s drought most persistent. AR5. In summary, the current assessment concludes that there is not enough evidence at present to suggest more than low confidence in a global scale observed trend in drought or dryness since the middle of the 20th century, owing to lack of direct observations, geographical inconsistencies in the trends, and dependencies of inferred trends on the index choice. AR6. Few AR6 regions show observed increases in meteorological drought. Now, they divide the world up into a whole bunch of regions, and each one has this 3-letter code attached to it. And the parts of North America where we are would be Eastern North America, I believe, but we're not listed in the list here. Mostly in Africa and South America, and a few others show a decrease. In other AR6 regions, there is inconclusive evidence in the attribution of long-term trends, but a human contribution to single meteorological events or sub-regional trends has been identified in some instances. In North America, the human influence on precipitation deficits is complex, with low confidence in the attribution of long-term changes in meteorological drought in AR6 regions. Drought, generally a bust. Tropical cyclones and hurricanes. Now this one, if a bad hurricane hits the U.S. South Atlantic region, you know that it's going to be blamed on climate change. The news, they'll trot out the people who will say, yes, this is a sign of what's to come, and this has all the hallmarks of climate change. All right, SREs. There have been no significant trends observed in global tropical cyclone frequency records, including over the present 40-year period of satellite observations. It thus remains uncertain whether any observed increases in tropical cyclone frequency on timescales longer than about 40 years are robust, after accounting for past changes in observing capabilities. Now, here one of the issues is we have global satellite coverage now that measures the entire process of a cyclone forming and dissipating. In the past, if a cyclone had formed over the ocean and dissipated, it might not have been counted. So some of the counts from the pre-1970s here are considered incomplete. AR5. Current data sets indicate no significant observed trends in global tropical cyclone frequency over the past century, and it remains uncertain whether any reported long-term increases in tropical cyclone frequency are robust after accounting for past changes in observing capabilities. No robust trends in annual numbers of tropical storms, hurricanes, and major hurricane counts have been identified over the past 100 years in the North Atlantic Basin. AR6. There is low confidence in most reported long-term multi-decadal to centennial trends in tropical cyclone frequency or intensity-based metrics due to changes in the technology used to collect the best track data. This should not be interpreted as implying that no physical real trends exist, but rather as indicating that either the quality or the temporal length of the data is not adequate to provide robust trend detection statements, particularly in the presence of multi-decadal variability. A subset of the best track data corresponding to hurricanes that have directly impacted the United States since 1900 is considered to be reliable and shows no trend in the frequency of U.S. landfall events. I warned you, this is going to be a boring talk. Now this is a data set, I don't think this is in the IPCC report, but this is the standard source of hurricane counts. This is a 12-month running sum of all hurricane counts. That's the top part of the line, and then the bottom part of the line shows major hurricanes. And so what you can see there is obviously this variability. There's a bit of a peak in the early 90s, and then since then it has tended to go down. And then another chart, I don't think I have it, but it's called the Accumulated Cyclone Energy Index, and it's an integrated metric of all the energy dissipated through hurricanes in the atmosphere. it looks very similar to that. There's not only not an upward trend, if anything, there's a slight downward trend over the past couple of decades.
What about for major hurricanes? Is there a trend in that in the bottom of the graph?
Let me see if I can reverse here.
Just a one-way presentation.
There we go. Well, I would say if we were to fit a line to it, yeah, you might have a. Actually, I would say that probably is portraying, because I think one of the points made in the last IPCC report was that the total number of hurricanes has gone down, but the fraction that become major hurricanes appears to have gone up. So, yes. Yeah.
So that's baseline is 1980, right?
1980, yeah.
Does it change if you like set a different, is there the same data set for a longer baseline?
The North Atlantic has a longer reliable data set for it. This is the global count, and it's especially over the Pacific Ocean where earlier records aren't available for a lot of basins. After 79, there's global satellite coverage. So this would be 1980.
And I don't see much of a trend there for the major ones.
Right, it's not a strong trend. I'm just going by eyeball, but I think after 1990 it kind of levels out. All right, tornadoes and severe convective storms. SREX. Thunderstorms, tornadoes, and related phenomena are not well observed in many parts of the world. Tornado occurrence since 1950 in the United States, for instance, displays an increasing trend that mainly reflects increased population density and increased numbers of people in remote areas. So here, this is one where the monitoring didn't really begin until the 90s when nationwide Doppler radar was put in place. Prior to that, they relied on people spotting them and reporting them. And so there'd be a lot of tornado events where it's just a brief touchdown of a funnel cloud, nobody sees it, and it doesn't do any damage. But now you've got, since the 90s, like I say, Doppler radar, but over time what's happening is more people are on the ground, and so there's just more observations happening. Over North America, a declining trend in 50th and 90th percentile wind speeds has been reported for much of the United States over 1973 to 2005, and in 10 meter hourly wind data over 1953 to 2006 over western and most of southern Canada. A number of recent studies have addressed observed changes in wind speed across different parts of the globe, but due to the various shortcomings and associated with anemometer data and the inconsistency in anemometer and reanalysis trends in some regions, we have low confidence in wind trends and their causes at this stage. We also have low confidence in how the observed trends in mean wind speed relate to trends in extreme winds. AR6. Observed trends in severe convective storms are highly regionally dependent. In the United States, it is indicated that there is no significant increase in convective storms and hail and severe thunderstorms. The mean annual number of tornadoes has remained relatively constant, but their variability of occurrence has increased since the 1970s, particularly over the 2000s, with a decrease in the number of days per year, but an increase in the number of tornadoes on these days. In summary, because the definition of severe convective storms varies depending on the literature and the region, it is not straightforward to make a synthesizing view of observed trends in severe convective storms in different regions. In particular, observational trends in tornadoes, hail, and lightning associated with severe convective storms are not robustly detected due to insufficient coverage of the long-term observations. There is medium confidence that the mean annual number of tornadoes in the United States has remained relatively constant, but their variability of occurrence has increased since the 1970s. And that's a record downloaded yesterday from the NOAA website, US tornado count. And so this goes back to 95. The record itself goes back a long way, and you can see it's sort of shaded out, but that's the trend that they talk about. They don't know if that's because there are more tornadoes happening. It's more likely that there are more being observed. And then this is the spot where the Doppler radar network comes in, and there's a step there, and then after that, it's variable, but there's no upward trend in the number of tornadoes happening. Notwithstanding the claim of the young lady from the NDP. Wildfires. Now here the IPCC doesn't have an assessment on wildfires. There's no section in their report on this, but we can look to other sources. So this is a satellite record from the European Space Agency from 1982 to 2018 of the global burn area. And so the black line is their longest satellite record, and then the green and the pink lines are from two shorter satellite records. And so what you can see is the point where we've got all three records together that begin roughly at the turn of the century, and there's no upward trend, and the colored lines actually show a slight downward trend. That's a global burn area due to wildfires, as measured by the European Space Agency. This is Canada's record, easy to find on the NRCan website. So the black line is the number of forest fires in Canada each year. And then the orange bars is the area burned. Now, first thing we have to say is 2023 was a spectacular outlier. And if you're going to say, well, that proves 2020 was also an outlier, but in the opposite direction. It was the lowest burn area in the record. So what happened in 2023 was forest fires broke out in regions with a ton of dead wood connected to the mountain pine beetle infestation a couple of decades ago. And those trees should have been cleared out, but haven't been. And around Jasper, there was a lot of complaints about the fact that dead wood there hadn't been cleared out, but it was supposed to be. But they caught fire, and the fires got out of control. It was a large burn area. But if you take out that outlier, there isn't an upward trend in the burn area, and there's a very clear downward trend in the number of forest fires. So when the environment minister, who ostensibly is in charge of this data, said or insinuated that we're seeing more forest fires, I don't know where she learned that. And if she'd asked any of her officials, they would have shown her this data, I hope. Now, forest fires are a hard thing to do any attribution to because we do aggressive fire suppression and have since the early 20th century. But what I will show you is that to the extent it can be reconstructed, today's wildfire activity is minimal compared to what would be happening in a natural setting. So we aggressively suppress wildfires, and I was a grad student at UBC in the 1990s when foresters began to warn that this much fire suppression is not good because there will eventually be fires breaking out, and you're letting so much fuel build up that they will become explosive. And that's what's happening now, where especially in some of the dramatic fires in the US, they just get explosive because there's so much fuel built up because we don't do the kind of clear-cut logging and forest clearing that was done prior to the early 90s. All right, this is from a 2016 review in the Philosophical Transactions of the Royal Society. Wildfire has been an important process affecting the Earth's surface and atmosphere for over 350 million years, and human societies have coexisted with fire since their emergence. Yet, many consider wildfire as an accelerating problem with widely held perceptions, both in the media and scientific papers, of increasing fire occurrence, severity, and resulting losses. However, important exceptions aside, the quantitative evidence available does not support these perceived overall trends. Instead, global area burn appears to have overall declined over past decades, and there is increasing evidence that there is less fire in the global landscape today than centuries ago. So, a few other indicators, moving outside of the IPCC. This is from a wonderful website called Our World in Data, run out of Oxford University. This is the fraction of world deaths due to landslides, drought, floods, storm, temperature, and wildfire. And well, I hardly need to point out, but this is 1968. Prior to that, there were some years where the fraction of world deaths due to climate, well, the peak was 0.18%, so it's never a huge number, but after the 1960s, it's basically nothing. A fraction of world deaths due to climate. Weather disaster losses. Now, this is a tricky one because the insurance industry puts out information that makes it sound like they're getting worse and worse, but there are more people and there are more buildings and there's more stuff in the way of any storm that goes through. So this article looked at that data but then normalized it for the change in the size of the economy. Since 1990, the world has seen a decrease in overall and weather-related disaster losses as a proportion of global GDP. This trend has occurred even as disaster losses have increased in absolute terms. The primary factor driving the overall increase in disaster losses is societal, mainly growth in populations and settlements at risk to the consequences of extreme events. And so this is a graph showing global weather disaster losses over the 1990 to 2017. That's the extent of the data set. And so there's some years where this is as a fraction of global GDP. Sometimes it gets up to the 0.4% mark, but most years it's a small number and kind of variable and not trending up in that chart. And then heat versus cold. So there is evidence there are more heat waves, but there's also evidence that there are less cold snaps. So which is worse? This is from a review in Environmental Health Perspectives in 2015. But while isolated heat waves pose a major health risk and grab headlines when they occur, recent research has uncovered a more complex and perhaps unexpected relationship between temperature and public health. On the whole, far more deaths occur in cold weather than in hot. This reality is obscured by the fact that, unlike heat-related health effects, which spike during discrete events, cold-related illnesses and deaths are diffuse throughout the year, don't require extreme temperatures, and can lag well behind cold snaps. And then the UK Office for National Statistics put out a study a couple of years ago, tallying up the number of deaths over the past 20 years due to extreme temperatures. Over a 20-year period, the estimated change in deaths associated with warm or cold temperature was a net decrease of 555,103, an average of 27,755 deaths per year. A decrease in deaths from outcomes associated with cold temperature greatly outnumbers deaths associated with warm temperature. So where you have this slow warming trend, yes, there are some more hot days, but there are fewer cold days, and on balance, that turns out to be a benefit, a net benefit. All right, so to summarize, contrary to popular sloganeering, expert assessments report few or no trends in extreme weather types at the global scale and conflicting trends at local scales, along with little evidence to support attribution of extreme weather to climate change or greenhouse gases. One very clear trend is the general global reduction of mortality risk associated with climate events. Additionally, a trend towards warmer weather and fewer cold extremes is associated with a net reduction in mortality risks. While weather-related insurance payouts are rising, this is fully explained by the growth in the size of the economy and the value of the insured asset stock. We could call this the heterodox mainstream of climate change.
Will they increase, if there is truly an increase in global temperature, so average around the whole world, I mean, there would be an increase in evaporation of moisture into the atmosphere. You think, or I don't know, I would expect. And
Well,
more precipitation, but then also more cloud cover, which obscures the sun that's heating, that's creating the problem in the first place.
Right, so first of all, the average water vapor in the atmosphere did go up for a while, but the last 10 years, for some reason, it's been going down, which is a bit of a puzzle. But one of the basic points about the temperature change is it's minimal in the tropics and it's stronger in the polar regions. And that means the overall temperature gradient is weakening, which on its own detracts from formation of extreme weather. Because what drives any weather system are gradients, not the averages. So there isn't a strong expectation automatically that warming should lead to more extreme weather. It's known, for instance, in the cold intervals, like the Little Ice Age, the proxy reconstructions showed it was a period of very intense hurricane formation during cold conditions. And then, and here this quickly exhausts any pretense of knowledge on my part, but hurricane formation depends not just on temperature, but also wind shear at different levels in the atmosphere. And some of the climate model runs suggest that the wind shear conditions become less favorable for hurricane formation. So all of these weather events, the problem is most of them are too small for climate models to resolve. They're below the grid scale models. And so we're dependent on just the measurements that we have to get some indications of what might be happening. And now I did a paper with a meteorologist a few years ago on precipitation trends in cities across the US. He put together daily precipitation records back to the late 1800s. He needed me to help with the statistical analysis. And precipitation data is very noisy and typically does not have trends in it. If you pick a subset of it, you can find a trend, but they do tend to reverse this phenomenon called long-term persistence in precipitation records. So years tend to cluster together. You get a really wet interval, and then it gives way to a dry interval, and you get these cyclical patterns in them. But now we showed that on any of the measures, average rainfall, median, extreme, 99th percentile, there were no trends over the whole data set. You can find little intervals with trends, but not over the whole century scale.
Yes.
So if the data and the IPCC overwhelmingly don't agree with the prevailing narrative on climate change, why is it still the prevailing narrative?
Why indeed? Well, there's an asymmetry there because I showed you the example of David Malpass, who actually said something true. When he was pressed, or he made this comment in a presentation that doesn't strike me as an emergency. And then there are armies of people that will attack you for that. But then I give these examples, and I could have given many more people right up to the top of all the governments, the UN, who frequently say extreme weather is getting worse and worse. And it doesn't seem to be anybody's job to demand some evidence from them. So there's this asymmetry of who gets attacked and who's given a free pass. And, then that Roger Pielke op-ed that I wrote about, it was, what happened there was he was at Colorado State, and he'd given testimony in Congress going through all this, just saying some of the things that had come up from the Obama administration weren't supported by the IPCC, at odds with the IPCC. And it was some Democrats who were really mad at him who then attacked him, filed complaints with the university, and it's quite a mess. So he wrote an article about it, and then I posted about it. But there, the weird thing was, okay, someone stepped up to challenge what he'd heard from some politicians. And he just used the reports that their own government had sponsored. And yet he was the one who was attacked with it. So, I believe we have a social psychologist here. I should actually get her to say what's going on, because it's nothing I can figure out.
Well, I'll ask, I won't answer that question, but I'll ask a related one. So you focus primarily on the data about what the current evidence is. And there are a couple of other columns in there, which I think are essentially projections, right? So what is anticipated. And so I teach about some of this stuff in my class, but the psychology and how we think about these kinds of things, and at least one of the things we talk about is temporal discounting, right? So we tend to focus on here and now. We're not so good at modeling certain kinds of thinking about the future. And to the extent that, and I'm not at all a scientist that has any real knowledge about what's going on with climate change. But to the extent that there is something to be concerned about that is likely to happen in the distant future, we as humans aren't very good at processing that information. We're pretty good at responding to immediate and quick moving threats. We're pretty bad at responding to or thinking about how to think about gradual, slow moving threats. And then all of the other things that are going on with this, I'm very interested in the psychology of activism and how for many activists, there's often a real impulse to communicate that the house is on fire and that it's, a 5-alarm emergency. And in some cases, that's done for strategic reasons because you want people to get really excited about things and act. Sometimes for good reason, but given where we're at with this issue, it's left me scratching my head about what's even true in some cases. And if we want to act to solve the actual problems that do exist or that we anticipate to exist, we need to actually be able to be open to all of the data, right? We just need to be able to know what's going on. And so to the extent that this is so politicized that some voices are being shut down entirely, that's actually counterproductive to any approach where we're going to actually figure out what's really happening.
I'll pick on that a little bit because I noticed there's a parallel in finance. I used to read finance blogs a lot more than I do now, but there are some perma bears, as they're called, and then perma bulls. And the bears especially love to give this impression that they have the inside scoop on the disaster that's about to unfold. Everything's about to collapse. And now the problem is sometimes there is a collapse. Like 2008, there was actually a financial crisis. And but I noticed after a while that there's kind of an enjoyment of feeling like you've got the inside track on some really significant information here. And you can advertise that by pointing to coming disasters. And so I find the finance blogs, not that people do blogging much anymore, but they were really similar to some of the climate blogs that way. I've got the inside scoop, I've seen the data, let me tell you, it's bad, and you gotta prepare and stock up on canned goods and ammunition because things are gonna really go off the rails. And my sense was, it's just kind of exciting to live on the edge of your seat like that.
Just a comment about kind of that. I saw research on narcissism being the leading trait in I think social activism or LGBTQ activism, something like that, which was something that I found very interesting. There's a correlation between that being the leading personality trait that is associated with activism. But I'd like to ask a question just in general. So does the data say, okay, fine, extreme events is a no, but that slow warming trend is not supported by the data? And are we saying, okay, that's real and that's human-made, or is that just a cycle of the weather where right now we're experiencing a warming trend, and in 50 years it's going to be a cooling trend?
So I would say yes, we are in a warming trend, which began in the 1800s. I think the best measurement of it comes from the weather satellites. You do have surface thermometer networks, which are most widely reported on, but the data is very sparse in most of the world. We don't have coverage over the oceans, so the satellite record shows a warming trend, and I published on the attribution. I'm really familiar with the method, and I think that method's it's just really hard to figure out. In fact, it's statistically impossible to figure out if there's a long natural warming trend. What you can do is you have a few candidate explanations. What they do is they look at the effects of changes in the sun, changes in greenhouse gases, changes in ozone, the things that you can measure, and then greenhouse gases have followed this steady upward trend. And so the regression model will say, okay, there's a trend here, we'll call that the greenhouse gas contribution, and then the other stuff tends to be small in comparison. However, what you wouldn't be able to say, if there's, say, some century scale variation in the amount of cloudiness in the climate system, the mechanism might exist but hasn't been proven, that intrinsically can't be distinguished. But the greenhouse gas story at least has the physical underpinning that CO2 is a greenhouse gas, so it does all fit together that way. However, that record, that trend, like from 1900 to the present, if that's the greenhouse gas contribution, it tends to be at the low end of what climate models are programmed to reproduce. In other words, climate models run for 100 years could generate just over 1 degree of warming or close to 6 degrees of warming. It all depends on the feedback processes. And so there's a field that does empirical climate sensitivity measurement, and then there's another group that do model-based climate sensitivity measurement. And the empirical stuff tends to be low compared to the range of models. So to me, that's sort of the plausible story at this point. It's a warming trend, greenhouse gas contribution. What we have so far is that it's pretty moderate.
So you talked about, I guess, extreme weather and the things that we should have observed or could have observed until now, if there was sort of that relationship between extreme weather and global warming. One thing, I guess, that I think a lot of people, at least in the public, have sort of deeply ingrained in somewhere deep in their heads is this sort of catastrophic, sort of global, systemic sort of failures. The ice caps melt, or I don't know what else. But they've got this sort of Planet of the Apes kind of scenario. Does the IPCC speak at all to sort of these, I don't know, these sort of tipping points, or that you kind of once in a while hear about?
They haven't really touched on tipping points too much because it's they're not present in climate models. I guess you could put them in, but then you're not learning anything. You're just sort of putting a tipping point in your model, running the model. Oh, this is a tipping point.
It's good science.
But the ordinary feedback process, the thing is, if there were tipping points all over, the paleoclimate record would show a lot more variability than it does. And there's over hundreds of thousands of years, there are big transitions in and out of ice ages. So yes, the system can generate huge internal instabilities. But over the 10,000 years of the current interglacial, if these runaway processes were there, it should have shown up before now. I think the only one that would be a candidate would be the Younger Dryas event, about 8,500 years ago. And there was a few decades, there was it was an extreme cooling and then a rapid warming, and then it went back to trend. And I think that's now attributed to the melting of, there was a huge inland ocean trapped by the receding glaciers, and they broke apart. And I think that was the last time I saw that. But yeah, on the tipping points, things like a runaway melting of the Greenland ice cap, for instance, or shutdown of the Gulf Stream in the oceans, or the breakup of the Antarctic ice cap. I guess the short answer there is you can make a model that would give you those things. But the IPCC doesn't really discuss it because it's hard to figure out what you're measuring and how. I hope they don't exist, but if they do, it's not obvious how we would know until it actually happens.
Does the IPCC consider solar radiation basically the primary source of our energy is the sun and the radiation that it provides to the Earth? How do they account for that, or possibility of variation in that?
Yeah, they used to. And then I guess it was the time of the fourth assessment report, so it would have been 2007. So there's a group of different solar reconstructions available This sunspot counts back to the 1600s, and then more direct measurements, and then in the satellite era that starts in the 70s. And the problem is the best satellite network that we have, the satellites wear out, have to be replaced. And the Space Shuttle Challenger, remember when that exploded? So that was carrying a replacement satellite for the system that measures solar radiation. So that meant there was this gap that opened up in the record. And the records have to be calibrated to each other. And so normally you have overlapping satellites, so they get precisely calibrated. That gap is the difference now between, there's one solar reconstruction that says there's been an upward trend in solar intensity over the satellite era, and another one that says no, there hasn't been any change at all. And so what the IPCC did was they said we'll go with the one that says no change. And so if there's no change in solar intensity, there's nothing to attribute to the sun. Now, I know a couple of people that have worked in that area, and one in particular who found an alternative satellite measurement that does overlap, that provided an indirect measure that, and he was at the Mount Wilson Observatory in California, and he said, no, I think there is really an increase in this interval. And the same old story, he got his work published, but that was more or less the end of his career. The solar people don't want there to be a trend, so there's no trend. Now, that's just total solar irradiance. There's also interesting differences in the way the spectrum affects different parts of the atmosphere. The attribution work is mainly directed at the total solar irradiance calculations.
Guess I could ask a question here. Sort of along the lines of what was asked already, is that often I see so many talks from graduate students, for example, in chemistry, biochemistry, biology, that start with the assumption that there are increasing wildfires, climate change is really a crisis we have to address, so now we're going to build whatever it is, that project is. So the IPCC seems to not support that, but presumably they're making that claim on something solid. So I'm just wondering, there must be a group of serious climate scientists who are in contradiction to the IPCC. And do they have a significant body of work that's taken seriously?
Well, this is the irony here, because there are scientists who contradict the IPCC on the solar radiation trend, and so you're not going to hear of them because the IPCC just waves them away. Yes, there are some scientists. Actually, I don't think there are any that would seriously question this. There's some that would say individual events like extreme precipitation in some regions of the world, or there's a theory that hurricanes now travel farther over land than they used to. That kind of thing gets debated. But you know, I see it in economics too. I see students, faculty, people will stand up, they're doing a paper on insurance markets or something, and it'll start just with a throwaway comment that extreme weather is getting worse, climate change means more extreme weather, we need to figure out how it's going to affect the insurance industry. And if I have any say, all I do is say, oh, can you give me some examples, and do you have any citations for that? And I've yet to have someone actually substantiate it. If they're students, I can take the sentence out as the, senior tenured faculty. But it happens in a lot of fields now.
Didn't Steve Kuhn, am I saying his name properly, in his book make a big point about the summary, IPCC 6, I think, misrepresenting the hurricane research and actually region or stating that there was a trend?
Yeah, this is another issue with the IPCC reports, that the summaries sometimes will twist the language just enough to make the headline that they want to see in the papers. And then, like what I quoted was always from the body of the reports, because you have to know where in the body of the report to read it. And there was something to do with hurricanes, where there was a study that actually was later retracted, but it was the basis for a claim that made it into the summary for policymakers. And so that's what, because the author of the paper that was later retracted was involved in writing the summary. And so that, the summary is a problematic area in a number of ways. And then since, I would say most journalists, the only part they read is the summary, but they don't even read the summary. They just read the press release, so that's a problem there. Yeah.
So, I wish there were people here that were, I wish there was a panel, right? And experts to say, oh, actually, this is what you're missing, or this is what you're getting wrong. Because that's what makes this so frustrating, is not being able to necessarily know the right questions to ask to critique.
Yeah.
But if someone were to say, well, you've cherry-picked the pieces of the IPCC that make the case you're making, could somebody go through and cherry-pick probably a similar number of pieces of the IPCC that would make a case, maybe they don't use the word emergency, but that would make a case that this is a much more severe and concerning issue than the way you're framing it.
I think on the extreme weather, you couldn't. So if I go back to the chart that I had here at the beginning. So this was their summary table. And the white boxes mean, this one means what's happened up till now. These ones, so this is emerging by 2050 and emerging by 2100. However, and I didn't talk about these columns, but that's for what's called the RCP 8.5 scenario, which is the most extreme upper end of warming scenario. And even with that, they don't even expect to see a signal emerge in any white box or an attributable trend in the pale boxes. So on the extreme weather side, if someone were able to go through the IPCC reports and come back with something like the popular view of extreme weather being attributable to climate change and getting worse and worse, I think they would have to cherry pick pretty carefully. Because, yeah, like the thing about these columns, and this is sort of, if I'd been a reviewer of this chapter, I would have said, you don't get to use RCP 8.5 for this, pick 4.5 or one of the mid-range scenarios, but RCP 8.5 is heavily criticized in the science literature because it envisions emissions that haven't happened and could never happen. And so, like I said, it's an extreme upper end, but even still, extreme upper end. And we don't observe it now, and we probably won't through the century.
So while I'll channel the critique person, you could say, like, there are some that are just white boxes all the way through, but if you got rid of the white boxes, there are more blue boxes as you go along, and I can't even read them well enough to know what they are, but it's arguable that the things that are the blue boxes are the ones that are going to be most concerning and impactful.
Orange are bad too, right? Like low decreasing sea ice, decreasing permafrost.
Yeah.
You know, so.
Right. Blue means an increase, orange means a decrease.
Right.
Now, you also have to distinguish between what's pale versus bright, and there it's not a great distinction, because pale just means we expect to see a change, but we can't necessarily attribute it.
Yeah. Because I would guess that people, like if you were to talk to the scientists who are on the IPCC, what would they say? Would they say, yeah, no big deal? Or would they be saying,
Well, actually, I'm a
Right.
reviewer of this report, so I read it since I published on the precipitation topic, I have no estimate on that. But there weren't a lot of changes in the drafts, I mean, this is what they said, and on the extreme weather issue, it's kind of the same with Environment Canada and the US National Climate Assessment, the team that does the extreme weather, they don't vary very much from these things, and it's because if they were, there's just so much literature on this now. Now, to your point, you're right, it would have been nice if someone who works in that field were here, if they had, I don't know, maybe I have missed stuff and we could have found out, but I would like to have heard their reaction to all the quotations. And it might be that some of the people who present themselves as experts on climate change haven't actually read all this stuff.
I'm fascinated by this obsession with carbon dioxide. It was driving all of this. And I keep thinking, is that a red herring, or are we like one of the issues? You know, so they're blaming the increase in carbon dioxide, and they're linking it to the increased use of so-called fossil fuels, hydrocarbon fuels. And in my mind, when I think of the chemistry behind that, a hydrocarbon fuel is hydrogen and carbon, right? And you oxidize carbon, you get carbon dioxide, you oxidize, but there's also a lot of energy released by oxidizing hydrogen.
Yeah.
And if you think of a fuel like natural gas or methane, which is the cleanest burning fuel there is, but there is, for every molecule of natural gas or methane that you burn, you create a molecule of carbon dioxide and 2 molecules of water vapor.
Mm-hmm.
And water vapor is what you see, whenever there's, you start your car up in the morning, what you see is not smoke, it's water vapor coming out of the tailpipe.
Right.
And water vapor, to me again, water vapor is, I've always read that as being the most, the primary driver of our weather. And so the more fossil fuel you burn, the more water vapor you're creating carbon dioxide, but you're also creating water vapor. And yet, and it gets back again with my previous question about, well, what if there's more moisture in the atmosphere? Why isn't that attributed as a cause of, so-called climate change?
So you're right that water vapor is a much stronger greenhouse gas than carbon dioxide. And most of the warming in a climate model is not from the carbon dioxide itself, it's from the water vapor feedback effect, which posits that if you have a little warming from carbon dioxide, the equilibrium level of water vapor that the atmosphere can hold goes up. And now, climate models view water vapor as endogenous, so it's determined by the conditions in the climate system. So a warmer climate, there's more water vapor in the atmosphere. And if you think about it, there's so much ocean surface that's going to be releasing water vapor quantities that make industrial emissions of water vapor, that doesn't matter. So the natural water cycle really governs the release of water vapor. But you also alluded to cloud cover, and that's a really difficult issue in modeling. We're trying to figure out how clouds form, what drives cloud cover, and over the past 20 years, there's been a decline in global cloud cover, and there isn't a clear explanation for it. But it doesn't
expect that trend to be the opposite. If we're creating all this CO2 from burning fossil fuels, we're creating even more water vapor.
Right. Yeah, it doesn't take much of a change in average cloud cover to start having a temperature effect, and because of the shielding of clouds on the surface. But when articles appear fairly regularly in Science magazine, but climate models and the cloud processes are always the big uncertainties, and it's just really hard to parameterize them and be confident that you've got it right. How they form, how long they last, what levels they form at.
I've been following this for a while, not as a publishing this, but I'm following some of this time series models and all the controversy and whatnot. One of the things that really, I think non-physical, you started to talk about physical processes. Well, CO2 is not a pollutant. So CO2 was declared a pollutant, and then that enabled the EPA to legislate. Now I got, the other thing is, in Europe, and one thing coming to chemistry, I don't know the field of this, maybe this is an open area, is I'm told that when a diesel engine burns, diesel fuel burns, it produces nitrous oxides, which are pollutants. It also produces particulates. So
Reduces that because it's burning, when you,
it's going at higher pressures.
higher temperatures create you create oxides of nitrogen, so the perfect combustion, you just get carbon dioxide
Exactly.
and
So,
water vapor.
what I'm wondering is, my perception is that there's been a sleight of hand that Europe has somehow, somebody has gotten everyone to drive diesel cars because supposedly it reduces the CO2, which is not a pollutant, but at the same time, the nitrous oxides, which are purported to be there, particulates are certainly there. One who's been in the diesel city knows that diesel buses driving. If you want to get less diesel and more gasoline, if you have a choice. Has there been any attempts, I'm just asking from an economic point of view, this might be an issue to ask economically, there seems to be been some decision made that was not optimized. It said CO2 at all costs. Let's ignore the idling, and then we have the Volkswagen gate and all that, you know.
I think you're right. Well, Europe does use a lot more diesel engines, and I think it was a rule around fuel efficiency that forced that.
And many Americans, I know Americans who went out and bought diesel Volkswagen because they could get like 50 miles per gallon and seem drive, road warriors.
Yeah.
There's no incentive for them to say, hold on, maybe or maybe not, this is actually producing a real pollutant.
Right.
Okay?
Yeah, we get
Versus,
knocks out
you know,
of we get knocks out of regular tailpipes.
yeah, I don't know the details in that, but it would be great
So
to
it's
see.
because we are using air rather than pure oxygen.
Yeah, it'd be great to do a hardcore economic ends analysis and all the stuff in your wheelhouse. This is something that could really knock it out of the park. I think because I have some ideas, but I don't have the numbers to justify that argument. Okay.
Yeah. Well, I would assume people have already looked at all the stuff around motor vehicle tailpipe emissions.
Don't assume anything. There's low-hanging fruit everywhere.
There's
Because if no one wants to know about it, you can write a paper because no one else is bothered.
there's some very good work on like the health effects of diesel and
Yeah,
so-
but I'm saying maybe there's something economic there to say, okay, here's where economics has failed us because we've made a wrong premise. The premise was CO2 was a pollutant. CO2 is as bad as NOx. So therefore, we got to hammer down on this thing. That's where I'm thinking.
In North America, those rules will be driven by the air quality standards, and Europe's are different from ours. In Canada, there's NOx in the air, but it has come down, and we don't really have any NOx issues as far as air quality compliance.
Yeah, so your earlier work on air quality, people aren't aware of this, earlier work on air quality showed that air quality is getting better and better, and then we had people like the Canadian Association of Physicians for the Environment telling us that we had a disaster, a panic, we had some kind of emergency, again, the word emergency.
And that was one where I start my classes each year just by showing students the Canadian air quality records. Most of them,
Exactly.
it doesn't even occur to them when we measure this stuff.
Yeah.
Find out, well, go to Exhibition Park in Guelph, there's an air quality monitoring station there, and you can see the numbers in real time.
Exactly. It's kind of a nerd core computer thing, but to point it out to the general public is very important, I think, because they don't know this.
One of the things that's happened here in Ontario is we shut down the coal-fired power generating station in Nanticoke, and supposedly it was green energy that replaced it, but really it was the gas plants that we
And also, we had put scrubbers in those in those coal stacks.
Yeah, shutting
Which
down the
would have
gas
removed-
pumps had almost no effect on air quality, because it was already very clean by that point.
Yeah.
Shutting down a plant in Toronto in the 70s had a big effect, because that was the Lakeview Power Station.
Oh, okay.
That was-
Etobicoke?
No, I think it was closer to downtown. But
Okay,
it was a big source of sulfur, and you can see in the record, it just drops off and that
Yeah.
closes down. And then scrubbers were installed, and they were partway through the scrubber installation at Nanticoke when the province ordered it shut down. But those scrubbers were already capturing 95% of the sulfur, so the shutdown, the marginal value of the shutdown was very small at that point.
It's crazy because there's a marginal value of the shutdown is small, yet there's got to be some term in economics for the cost to recover that asset. You've closed a door, you could never refire those. Suppose there are reindustrialization of steel. Suppose Canada decided to become a steel producer again. We could have had those towers there, and we could have made steel, and we could have cogeneration for electricity. We could have had it made, and some guy decided to take them down because he wanted to block the forward path.
Yeah,
It's like the
And that was-
pipeline, the Nord Stream pipeline. Cut it, there's no forward path.
it was one of those classic cases where as soon as the discussion came up, it was shut down. 'Cause
Yeah.
I remember writing about it at the time and saying, well, look at the numbers we're getting from these scrubbers. They're doing everything that you want to do, but we could at least let the plants run out the rest of their life, except the inexpensive electricity from them. But no, it was the pamphlets put out with kids breathing with the asthma puffers and this claim that it's killing everybody. And but we had loads of air quality monitoring data and the emissions data from the plants themselves, but by that point.
I didn't realize you had emissions data from plants. I just knew you had, it's like all over Ontario, you have emissions data. Yeah, thank you.
I think the name you're looking for is Dalton.
Yeah.
Said some guy.
Yeah. We all know that.
Yeah, he was the guy.
I think we're gonna have to wrap this
Yeah.
up. But Michael, do you want to make a closing?
Oh, no, go ahead, yeah.
Oh, well.
Wrap it up,
Thank Ross
yeah.
McKitrick for coming on with.
Thank you for coming out on a sunny afternoon.